Hello world, it's Calcutron here with the 6th installment of our TI Basic tutorial series. Up until now, we've been able to write programs which execute from top to bottom. This path of execution through your program is called the program flow. Using if and else statements with Boolean conditions, we're able to branch the program flow to run through a block of code, or skip it. This makes if a control flow statement and is why we find it in the Control tab, or CTL tab, of the program editor. Another way to skip over code is using the goTo statement to jump to a specific label in our code. Let's take a look at this in a test program. But first we should review how if statements work, because there's a small piece to how they work that we may have glossed over. And that is that an if statement, and here's the condition C, with no then and end statement will only run the next line. So this will only run this line, the line after the if, when C is true, but it will always run this line. It will always run the AAA, regardless of whether C is true or not. But if we want to run multiple lines, we use an if then end. And then when C is true, both the ellipses and AAA will run when C is true, and both won't run when C is not true. So that was something we might have gone over quickly in our video on conditionals, and it's something we're going to take advantage of today. So let's start by writing a simple hello world program, but instead of writing it on one line, we're going to write it on 2 lines. And if we run it, we get hello world on 2 lines, just like we expected. Let's go ahead and put in a clear home at the top too. Oops, that's not clear home. Oops. Clear home. So like I said, today we're going to be talking about labels and goTos. So let's put a label into our code, and we'll put it right here. And labels, if we see, they're in the Control tab of our program editor, which means they are a control flow statement. So let's put in a label and see what it does. But first we need to give the label an identifier, and that's a 2-letter or digit code that tells you what is the name of this label. So like I said, it can be 2 letters, 2 numbers, a mixture of letters and numbers, or it can also be a single letter or a single number. Let's start by using single numbers, since I think that they're rather easy to read. One thing that might trip beginners up is if you use labels that are a single letter, like label A, it is in no way related to the variable A. It is just the identifier that you use to address or to talk to this label in particular. But let's use numbers to avoid any confusion with that. So now when we run our test program, we get the exact same thing, with the additional clear home at the beginning. So this is exactly what we should have expected without the label. So if adding the label in didn't change the way our program behaved, we can have a pretty good guess that labels by themselves don't have any effect when they're executed. So when your program is being executed, the first line is going to be clear home, and then display is executed, and then this label one is executed, but it has no effect. It doesn't clear the screen or display anything. It does nothing. So labels are just there to label pieces of code. So if you were writing a text document, you could label a line of your text document, and then people reading it in the future would be able to see, oh, on line 10 or at label 5, he had a spelling mistake. But that label in your text document doesn't actually change the meaning of the text. It doesn't change how one reads it. It's just there so that you can reference different pieces of the text. And it's the exact same way in programs. So labels won't change how your program executes, but you can use goTos in order to jump to a label. So you use goTos, and then labels become useful. So let's put in a goTo on the first line of our program. And goTo is another control flow statement, and it's all the way down here in 0. So you can either scroll down to 0, but what I like to do is hit Program and then just hit 0. And as you work in TI Basic longer, you'll start to memorize these shortcuts. So we'll go to label 1. And now when we run this, what happens is it doesn't display world and it doesn't clear home. So let's take a look at our program. So what's happening, I think you can guess, is that when it gets to this goto, it's going to immediately jump the execution. So the flow is going to pass right by this clear home and this display, and it's going to jump to label 1. So hopefully all of these programming terms we've learned so far are fairly self-explanatory. We've already seen that if and or, those work very similarly to the way they work in English. And it's the same with gotos and labels. We want to go to this label in our code. So hopefully you can have some intuition about what a command is going to do before you've ever seen it used. So what we have right now is not all that different from the if statements that we've been using, as in it skips a piece of code. But what an if statement does is it skips a piece of code conditionally. So what we could actually do is if we wanted a multi-line if, so an if then end, what we can actually do is put a condition before this goto, put an if, so if C, and then let's go ahead and prompt the user for C, and let's just do input C for brevity. So if C is true, it's going to do this goto. If C is false, it's not going to do the goto, and it is going to execute the clear home and the display. So this is just like a multi-line if, except it only uses one line for the if. So alternatively, well, let's run this. And we'll put in a 0, and it won't. So I have been tricked. Well, not really tricked, but I miscommunicated earlier. And it's actually, if C is true, it's not going to display the code if C is. So I probably explained it right, but in my head I was thinking when C is false it won't do it, and when C is true it will do it. So let's make that the case, and we'll put in a not. And just as a refresher, we get to the not by doing second math, and then we go over to the logic tab, and it's the 4th menu item. So now if not C, so that means when C is true, it's going to run the code. When C is false, it's not going to run the code. So there, when C is false, it's just like an if statement behaved, and it won't run the following code. And when C is true, and remember true can be any non-zero value, so we'll put in -1, it runs. So that's how we can convert all of our if statements to use single line ifs with labels and gotos. But one interesting thing we haven't seen, or you might think would be interesting to experiment with, is what if we put our goto below our label? And this is where we start to get really interesting and useful behaviors. So here we'll go to label 1, and now when we execute this, we're going to get a loop. So you might not be able to tell, but it's constantly refreshing the screen, adding a new world to the display. And this is going on forever and ever in an infinite loop. So the only way to get out of this loop is to hit the on button. And that will break our code. And we can do this any point in a program's execution, is hit the on key, and it will break the code, and then you have the option of going to where the code was when you broke it. So as we can see, that created a loop. As soon as it got to this goto statement, it looped back up to this label, and then it did the display again, and then it got to the goto once again and looped to the label. So infinitely it was displaying goto, or sorry, it was displaying world and then going back to the label. And while infinite loops can be very useful, most of the time we want loops that aren't infinite. We don't want our user to have to press the on key in order to get out. So what we can do is have this conditionally go to. So now let's say input C, and then if C, go to 1. So if they put in a 0, it's going to end the program, so it's not going to go to. If they put in a 1, it is going to go back to label 1, and it's going to loop. Let's try this out. So it runs the loop once, it displays world once before getting to our input, and now if we hit 1, it'll loop again. Or we can also put in 2, or once again 0.6 is also true. As soon as we put in 0 though, it stops looping. It doesn't do the goto, because it was only conditionally running the goto because of this if statement. But what if we want our code to only run through the loop if we put in a 1 the first time? So in our current program, like we saw, it always displays world at least once, even if we put in a 0. But what if we want it to first ask us before going into the loop at all? And what we can do is move this up here just inside the loop. So we want our input into C, and then if C, and if C is true, we want to, or if C is false, so let's put in a not here, we want to exit the loop. So they'll put in a 1 if they want to keep looping and a 0 if they want to stop looping, just like before. But how are we going to break out of this loop? How are we going to skip this goto if it's all the way down here? And the way we can do that, well, we could put in a then and reverse our if statement, but what we can instead do, let's go to label 2. And now we have to put in our label 2, and we want label 2 to be down here after the end of this loop. And then we can have it display done, even though it already displays a done message, but we'll have 2 done messages. So now, if they input anything that is not true, so if they input a 0, it's going to be not 0, so this if is going to execute this goto, and it's going to skip past displaying world and displaying and going back to label 1, and then it's going to display done. So let's try this out. So before entering the loop at all, it prompts us as to whether or not we want to enter the loop. So the first time around we'll say, yeah, ooh, this is exciting. But eventually we get bored of it just outputting world, and so we can hit 0, end the loop, and now it's done. And what often happens is when we make mistakes programming, we can accidentally create infinite loops. So it's possible that we could put in a 1 in here by accident, and then it would be an infinite loop because we'd never break out to this label 2. We would always go back to this label 1, and sometimes we would go to label 1 after displaying world, but this is still an infinite loop. So if we put in a 1, it'll display world. If we put in a 0, it's going to keep looping and prompt us again. And something you have to remember when you're writing TI basic programs is to use the on key in order to break out of your program. So always remember on break. Very important when you're starting out with loops is that you know how to break an infinite loop. So currently we're asking the user if they want to exit the loop, but what if we want to say loop 10 times and then exit? Well, what we can do is create a count controlled loop. So what we have now is a condition controlled loop, because we have our if statement with our condition here as to whether or not we exit, and that condition is not controlled by a counter. So in order to make this a count controlled loop, we just need to change this condition, and we can take out this input, and let's say we want to loop 10 times. So let's use the variable a to count. So we'll start by storing 0 in a, and then every time through this loop we want to count up. So before the end of the loop, let's put in a line that will increment a, or increase a by 1, or count up. So the way we do that is by doing a plus 1, and if we just do that, it's going to add 1 to a, but we want it to update a, so we have to store the result into a. So this is going to increment a by 1, and then we go to 1, so it's going to do this loop, and we want, if a is greater than or equal to 10, to break out of this loop. So it's going to go 10 times through the loop, and then when a reaches 10, it's going to go to label 2 and break out of the loop. So it'll loop exactly 10 times. Let's see. 1, 2. So it all happened very fast and we couldn't count 10 times. So what we can do is we can display world and we can display A. And we can do that by separating them by a comma, or we could alternatively have used another display statement. But a comma is a little bit more elegant way to do it. So now it'll display the value of the counter through every cycle of the loop. So you can see it now, it's going A from 0 to 9. And that is our first count-controlled loop, as well as in this episode we created our first condition-controlled loop. That was the one where we prompted the user as to whether or not they wanted to loop again. And we also saw how loops are tied to multi-line if statements, how gotos and labels are tied to multi-line if statements. So there's a lot more uses for gotos and labels, and I hope that we can get into more of them later. But before we end this episode, I want to say a caution that gotos and labels are often, in higher level programming, considered bad practice to use. So if you're ever programming in another language like C or C++, you may have even heard that gotos are considered harmful. That's a very famous title of a paper by Edgar Dijkstra. In the early days of computing, people figured out these gotos that we created, they can be useful, but they're often considered harmful. And we'll talk a little bit more about why we shouldn't use gotos in our program, and it's because of something called spaghetti code. But just know we're going to be using them in the next couple episodes, and they can be very useful, and there is one time when I think we should use gotos, but in general we should be trying to avoid them as much as possible. So we've learned a powerful tool, but with great power comes great responsibility. So get out there and use gotos for now, but we're going to learn better tools to accomplish the same tasks as gotos in following episodes. So I hope you enjoyed this episode. If you have any questions or comments, please leave them below. Bye-bye.